Swayam Prabha. Digital India. Educated India.
So welcome back. In the previous class we were talking about different type of channel forms, and we discussed about straight, meander and braided. So usually what we see, the braided channels or the braided rivers are a bit dangerous in the sense because they have the typical coarse grain they carry, and they are generated where you are having a steeper slope or the channel or stream entering in from the steeper slope to the gentler one. So the energy conditions will be different here, and usually what happens is that it will try to dump all the material or the bed load which has been carried from the uplands in the region. So this is typical of the braided system, and the landforms or the features which are seen in between are your braid bars. Another one is the meandering pattern, as we discussed in the previous one, that the outer side will be erosive and the inner side will be depositional side, which we call as an point bar. And in this type of channels are mainly seen in the alluvial plain areas, and in particular if you take in terms of the Indian side, we can see this in the Indo-Gangetic plain. So the channel has a tendency to even produce the cutoff banks which have been seen here. This is one of the example of the paleo channel, which we say as a cutoff bank, because the outer side is both erosive, and the time will come which will move closer to one another, and this portion will be left out. So for example, this is an erosive side, this is also an erosive side. The time will come that this channel will join here, leaving this portion as an cutoff channel. And having this shape, we also term this shape as an oxbow, or feature as an oxbow lake. Now if we take the overall cross-sectional view or of mainly the meandering channel, which also includes of course some part will be the straight. So what we learn from here is that this portion will be the deeper part with the higher energy condition, and the inner side will be the depositional side, whereas the straight channel, as we discussed, the pool area will be in the center part, where will be the deeper, as well as it will have the maximum energy conditions. Meandering dynamics, if we take again the same part which we discussed in the previous one, so the deposition will keep on taking place over here, and the channel will keep migrating from this in this direction, whereas the erosion bank will also migrate towards this side. So as we were discussing in one of the slide, that if we have the urban settlement sitting on the top of this one, this is not an ideal situation, because this bank is an erosive side, so it will keep on eroding during the peak flood. So we have the maximum energy conditions over here, which is termed as the talvage, that is the area of maximum slope and higher energy, whereas this portion, which is the inner side, is termed as point bar. Another important aspect of this is of course in terms of the cross sectional areas, as well as in terms of the grain size. If you see, then we will have the coarser grain size in the straight channels, whereas if you have the meander where you have the sinuosity, then you have inner side mostly you will find is the finer deposits, whereas in the deeper side, that is an outer side, you will have the coarser material setting. And of course, the velocity conditions will also vary from the straight to meandering side. There is a high resolution satellite data of Indo-Gangetic plain which marks the different segments, and this particular interpretation helps us in identifying the different flood zones or the flood hazard zones in the region, because we should not allow, for example, to go for any or allow any construction within the active floodplain. So we have the older floodplains in this region. This portion, whole portion, is an active floodplain. So river will have a tendency to migrate. That is what we are looking at, the river migration or avulsion. So this will be in common tendency of the channel, meandering channel, to migrate from one place to another place, leaving behind the paleo channels. So you can see within the active floodplain, we have a lot of meandering scars that has older channels or paleo channels, we can say, and they will be later will get converted into or the oxbow lakes, whereas this part is an older floodplain. So the older floodplain, after detailed identification and classification, one can go for the urban settlement in the older floodplain, and with an understanding that what will be the peak flooding conditions or the flooding condition during the peak discharge. So basically, one should avoid this region for coming up with any sort of a construction. So we have one example we'll talk later from Himalaya, and partly I think we discussed in one of the class where we were talking about the landslide, and that example is from Dehradun. So erosion, carrying capacity and channel shape. The erosion pattern in the stream bed can change dramatically during flooding events. Example, an increase in discharge during a flood causes increase in water velocity, water depth, and also the width of the stream. So during floods or in the monsoon season, the channel morphology will be slightly altered in terms of the depth and in terms of the width also, and that will also depend on the carrying capacity of the channel. So this happens because as water depth and the velocity increases during the flood, shear or the drag at the bottom of the channel increases, and this will result into the deepening of channel at places. So this extra shear picks up more sediments and increase the erosion. So you can remember that during the floods, you will have increase in erosion as well as more sediments you will have, and the bottom of the channel will also be increased. Okay, so water depth will increase and the width will also increase of the channel. So if you look at this figure, it talks about that how the channel dimensions will change over the time. So here what it shows, this is an example of San Juan River from US, and it shows that it has a low water flowing through it during September 9, 1941, and then this was its normal depth. But with early water rise, that was on September 15, during the same year, sediment from upstream deposited to raise the channel bottom. As the water rose from further to to the maximum level that was on 8 October 14, that was the time when the channel eroded to its deepest point. So, this is the deepest point, and usually it used to remain here. So, you can understand that the water amount has increased, even the channel cross sectional area has increased. As the flood level went at the time when the water came down, okay, at that time, that is on 26th October, sediment again got deposited. So, channel pattern or channel shape will change during the flood, before the flood, and it will be different after the flood. Now, there are two types of channels usually are been seen in different climatic zones. If you are having a wet climate, then mostly what we see is that channel is getting recharged from the surrounding water which is getting into the channel, that is based of either you can say the recharges from the watershed areas through underground movement of the water, but in case of the dry climate you continuously lose the water because you have a thick zone of unsaturated units. So, this had been termed as gaining streams, where the water is continuously gained, whereas this one is your losing stream. So, in wet climates, groundwater flows into the gaining streams, ensuring year round flow will be available here, whereas here in the dry climates water from stream feeds the groundwater. So, you will continuously keep on losing, and this losing streams may dry up between the rainstorms. So, you will not find this stream having or carrying water throughout. Now, apart from that, the gaining and the losing streams, the important part is your landforms which are associated with this. So, we looked at the point bars, we looked at the deeper part in the meander, but here what this is very most common landform which will be available through the valley, and these are termed as terraces. So, terraces are nothing but the abundant floodplains of the same stream, and then there is slightly elevated portion which will be observed in most of the areas along the stream will be your natural levees. So, if you take the profile here which has been shown, so you have the channel boundary or the base or the bed of the channel, then you are having the elevated portion and then it slopes away from the channel. So, both the sides. So, in some areas if this natural levees are not available, then people try to construct artificial levees, and this is mainly done for protection from floods. So, in that case what has been done, of course, if the flow or the stream when it is in the flooding state, if the water depths are so high that it can inundate the close by floodplains or the terraces, which usually we also term this as a younger terrace and this is an older terrace, or you can say younger alluvium floodplain, and the older floodplains. So, if we understand that this region may get inundated in near future, then one should avoid putting the construction in such areas. That is what is we can also talk about the active floodplains. So, these are very young terraces which can get inundated. So, with an understanding that such landforms, about the landforms, one should go for the urban planning. The river and related landforms. So, if you have for example, no natural levees are available over here, but then also we need to utilize or acquire the floodplain areas for urban settlements and of course for the having the farmlands. So, what best we can do is we can go for an artificial construction of levees. In most of the countries and in some cities in India, we have done this to protect the surrounding or the adjacent area or the floodplain from the flooding state. And what we can also say this as that we have channelized the flow or river training. So, we have tried to train the river and force the river to flow within this zone. It will not overflow, of course, with an understanding that the peak floods have never crossed this level in the past during the historic time. So, with that understanding, we can allow people to occupy the older flood or the younger floodplains and also use the area for agricultural purposes. Now, advantage of natural levees, of course, as we have discussed, that we will be able to utilize the fertile land, that is the floodplains. And if you see this photograph, it shows that there is a construction of a levee, and this whole patch has been used for the urban development. So, houses are built on natural levee along a channel and floodplain this is from the Mississippi River. Now, this landform is important, but we will quickly move to what exactly the role it plays in the flooding events, and we will talk about the features where exactly they are available. So, similar to the deltas, the alluvial fan feature is mostly seen close to the river front, okay, or sorry, the mountain front. So, where you have the steep valleys, and then suddenly the elevation, the gradient changes to flats. For example, we are having the Himalayas, and then we come down to the flat area. So, river flowing from here gets into the plain areas. So, this will be the portion where the river will experience that is a decrease in the slope from the steeper to gentler, and the corresponding drop in the velocity also will be observed, and a decrease in the ability of the carrying sediments. So, if there is like cloud burst or an sudden outpour of the water in such regions, then this portion becomes very dangerous or hazardous, because it will as soon as the slope changes from steeper to gentler, then it will result into as what we were talking about, that there is a decrease in its ability to carry the sediment. So, what it will do, it will just dump the material, and since it is coming from the steeper side, it will tend to carry coarser bed load. So, sudden outpouring of the coarser bed load in this region will affect the settlements and any structures which have been put across it. So, as a result, the stream deposits its load in fan like shape. So, as soon as it comes away from the front area, it will remain confined here. So, there is an elevation change. So, it will try to dump the material, and the shape which has been seen is typical like a fan. Hence, it has been, so you have a loose material and the shape is fan like and is termed as alluvial fan in the region. So, this will be a topographic break. And the slope here will be steeper, and this side it will be gentle. Few examples of the alluvial fans. This one is extremely beautiful, which typical. So you have a confined channel, and then as soon as it debouches into or onto the flat areas where the slope is reduced, it will spread out in multiple channels and deposit the material in a fan shape. There is an example from India where you are having the mountain front here, there is Shivaliks, and you have an Indo-Gangetic plain. So the alluvial fan has been deposited over here in close to Chandigarh area. So one of the best example again, that you have a confined channel from here, that is Kosi, and then you have the channel which takes the outer boundary of the fan area. So if you draw the fan here, then it will be something like that. So you have an alluvial fan. So this is a Kosi alluvial fan, and on the fan, the Kosi fan, what we see clearly is multiple channels. Okay, so we have some channels with little water. Otherwise, most of the channels are the dried up channels, and these are all paleo channels of Kosi. So you have, one is the alluvial fan, and this Kosi river has experienced or has a tendency of migration from one channel to another one. Some people believe that this fan shape of the Kosi is because of the two faults in the region, which has resulted into the or played an important role in shaping up of the fan landform, fan-like landform. But what we if you go back into the history, then you will find that at some point of time these channels were been occupied. Like for example, we have 1922 to 1948, the river flowed, or the Kosi flowed, taking this path, whereas recently it is flowing along this one since 1983, and this one is 1950. But in some years it also flowed through, like this is, if I am not wrong, is 1231, and then you are having 1770, 1807 to 1834, and so on. So it has a tendency to migrate from one place to another place, and the reason for this, usually what we see is that the cross sectional area over here of the channel. So channel cross sectional area is reduced over the time, or it has been reduced. So the reason for this is the higher amount of bed load, and this could be related to the deforestation in Nepal, whereas most of the area in catchment is subjected to erosion. So the erosion will result into the more of the bed load. But this is one reason, but another reason could be the ongoing tectonic deformation in Nepal Himalaya. So in Nepal Himalaya mainly we have major fault system, and ongoing deformation will definitely result into more shearing plus fracturing of succession, triggering more erosion because Himalaya is rising continuously. So there are a few things which are important, and we, with this understanding that this river has a capability or tendency to migrate from one channel, or it has a tendency to reoccupy its own paleo channels, we need to be careful allowing the people to settle down along such channels, paleo channels. Now coming to the another the flooding pattern in the upstream and the downstream. So usually we can classify this as an upstream flood and downstream flood. So floods that affect smaller areas, okay, are the upstream floods. They are localized and are caused mainly by local cloudburst, rain, storm or dam failure. Then you have that the time it will last for, it will be for a very short period, whereas the floods that affects larger area, that is in our downstream floods, they will affect larger area in downstream, caused mainly due to prolonged heavy rainfall in its watershed upstream, last for longer period. So these are two important part that usually where exactly we are located is important. So upstream flood and downstream floods. Downstream flood and storm condition, even with intense rain storm locally on a small drainage basin, there will be a lag between a storm and the resulting flood peak, because how fast the stream will enter into the flooding state. So this is the intense rainfall locally on a small stream or the storm drainage basin, there will be a lag between storm and the resulting peak. Example, a torrential downpour may last for only 10 minutes, but it takes time for the water to saturate the surface layer of soil and percolate down to the water table, which will, what we were talking about, the gaining stream and all that. More time is required for overland flow to collect in small gullies and for water in those gullies to flow down to a stream, that is the small tributaries getting in the water into the main stream. So more time will be required for the overland flows. In turn, it takes time for the water in small stream to combine and cause flooding in a large stream. So if you are having more streams available, then you may have the flooding quickly in the larger streams, that is the trunk streams which we are talking. So this is an example which has been given for that if you are having in torrential rain precipitation in this area, the lags will be different. The discharge A at A, discharge B and discharge at C. So localized rainfall, this is an example from Tucson, Arizona, and this figure which shows about the storm rainfall entering a stream beside the flood crest that is caused. This is the flood crest, actually the peak. So the flood hydrograph nearest the rainfall area is highest. So, this was close to the area where there was an excessive pouring out of. So, this region will have the highest and the narrowest peak. So, very quickly you will have the area getting into the flooding state, whereas farther downstream at location B over here, okay, the flood hydrograph. So, what we are looking at is basically the time here and the amount of precipitation, the rate of precipitation and discharge, and the time taken between the first peak of getting into the flood state and the last one. Okay. So, at location B, the flood hydrograph crust at a lower level, but lasts longer. So, what we are able to learn here is that in the upstream area, it will quickly die out. The flood will definitely enter into the channel will definitely enter into the flooding state and will have higher discharge, but it will last for very short period. Okay. Whereas this one, it will last for longer one. Further downstream, it will last for further longer. So, the C, that still further downstream at C, the flood crust at an even lower level and last longer. So, within the drainage basin, where exactly you are located is also an important role. So, you have a drainage basin like this, for example, and where exactly you are located, either you are located in the upstream area or the downstream area, or middle part or the downstream area, then accordingly you will be able to see these peaks. So, drainage basin evolution and morphometry drainage pattern we will discuss quickly. So, we will stop here and we will continue in the next lecture.